These are the solutions for the formative for 5.4, graphing and modeling with sinusoidal functions. So in the first example, or first question, we're asked to sketch one cycle of this graph. Y is equal to minus sine 3x plus 180 degrees quantity minus 2. So in order to graph this, we need to get our A, K, D, and C values so that we know the transformations of it. So in this case, first of all, we need to factor out the K, so we get the proper phase shift on this. So this is same thing as minus sine of 3x plus 60 degrees minus 2. So here we can see that there's going to be a reflection in the x-axis, or a vertical reflection, because our A value is minus 1. That implies our amplitude is 1, but we don't actually need to know that in order to graph it. Our K value here is 3. So from that, we can get our period. So our period for the equation is 360 divided by K. So in this case, it's 360 divided by 3. So our period is actually 120 degrees. The next value we're going to look at is D, which is in this case minus 60. Okay, so remember, to me, this is what makes inside our bracket 0, what value of x makes that 0. So it's going to be negative 60. So this implies a phase shift of 60 degrees to the left. And finally, we have the C value, which is negative 2. So that implies our equation of axes is y is equal to negative 2. The reason I keep pausing because I'm thinking of the A value. It is important that here we have the amplitude is 1, because this is going to tell us how far up and down to go from the equation of axes to get our graph. So in order to graph it, another thing that we need is we need the intervals. So here the interval, our general equation was going to be the period divided by 4. So in this case, the period was 120 degrees divided by 4. So we have an interval of 30 degrees. Why do we divide by 4? So if we remember, our sine and cosine graphs is really broken up into 4 distinct parts. So let me quickly sketch the sine. So again, it's going to be off into 4 distinct parts, each having 1/4 of our period. And then we know that sine starts in the equation of axes, goes up to the peak, back down to the equation of axes, down to the trough, and back to the equation of axes. So it looks something like that. And that's always going to be the general pattern of our sine curve. And since I'm here, let me review the cosine. So again, it's going to be at regular quarter intervals. And that's going to be actually really important for the next question. Is for cosine, we're going to start at the peak, go down to the equation of axes, down to the trough, equation of axes, and back to the peak again. So it looks something like that. So let's label our axes at 30 degrees. So this is going to be 30, 60, 90, 120. And I'll keep going just in case. 180 degrees, and go to the left where you get negative 30 degrees and negative 60 degrees. So when we go off to graph it, we wanted to get our equation of axes so that we know what the halfway point of the graph is. So here it is right there. And we know that we have a phase shift of 60 degrees to the left. So that's what we have over here, 60 degrees to the left. And so we know that sine starts at the equation of axes. So we're going to have a point right there. Now we know that it's going to move across in quarters, so every 30 degrees. Now normally sine goes up. So over here, normally sine goes up. But because here we have a reflection, it's that graph reflected. So what's going to happen is the net effect of instead going up, so let me graph this and maybe in green, instead of it going up, it's actually going to come down, back down the equation of axes, going up and back down to the equation of axes. So the graph of sine reflected will look something like that. So we're going to emulate that pattern on our graph. So here we go 30 degrees and we want to go down an amplitude of 1. So it's going to be over there. We come back to the equation of axes. Then we go up to the peak, which is going to be 1 up from the equation of axes and back down from the equation of axes. So that's what we call the 5-point graphing system. And let me sort of connect the graphs now in a sinusoidal curve. And so it will look something like that. So that's one cycle of this graph. Notice that here we could have started over here and gone this way as well, if that's what we want, but to me I just used the actual phase shift of 60 degrees to the left. Now the next question is, you can think of it as a word problem, but not really. It's really we're given a graph of a graph. You can think of it as we're given a graph, but we're given a description of it as opposed to the graph itself. So here we're given some key information is that we have a maximum happening at negative 60 degrees, comma 12, and a minimum of 40 degrees and negative 8. So in order to come up with an equation, and this one is actually asking for sine and cosine, and I'll give a hint on which one we actually want to start first, but we'll always want to get our A, K, and C values. That is always going to be the same regardless of whether it's a sine or cosine. So how do we get these things? Well, let's take the information that we have and we're given the peak. So here we have the peak. The peak value is 12. We're given the trough, in other words, the minimum value. The minimum value is negative 8. So from there, we could always get two pieces of information. One is the amplitude. So equation for the amplitude again is peak minus trough over 2. In this case, the peak is 12 minus negative 8 over 2, which is 20 over 2, which is 10. So from there, we could get the A is actually 10. Coincidentally, A is amplitude starts with A. The other one we could have is the equation of axes. In other words, our C value, and this is going to be peak plus trough over 2. In other words, the average of the maximum and the minimum. In this case, it's going to be 12 plus or minus 8 over 2, which is 4 over 2, which is 2. So that's our equation of axis is 2. So that implies that my C value is 2. Last thing is that we could get from this is the period. Now, it seems like we can't because we're not told where it might be ending again. But one thing we know with the sinusoidal function, or actually, is that if we're given the maximum and the minimum, the distance between the max and min will always, always, always be half the period. And that goes back to what I said before, in that in terms of sinusoidal curve, it's always broken up into 4 parts, and we can see 4 equal parts, and we can see that always between the minimum and the maximum, minimum and the maximum is going to be half the period. So here we can say that the maximum is happening at negative 60, the minimum is happening at 40, so the distance from negative 60 degrees to 40 degrees, really we calculate this as 40 minus a minus 60, and so that's going to be 100 degrees, so that implies my period is 200 degrees. So how does that affect my K value? Well, K we know is going to be 360 divided by the period. In this case, it's going to be 360 over 200. And then we can simplify that to be 36 over 20 divided by 4, so 9 over 5. Let me double check. Divide by 40, yes, 9 over 5. So right off the bat, we got 3 parts of our 4 equations. And the reason why I said that it's easier to start with the cosine is because we know that cosine always starts in the maximum. So in this case, for the d value for cosine, we know that this is going to be a phase shift of 60 degrees to the left. So the d is going to be negative 60 degrees. So our equation for cosine is y is equal to 10, that's my amplitude, or a, times the cos. My k value here is 9 over 5. In this case, my phase shift is 60 degrees to the left, so x minus negative 60 is going to give me a positive 60 degrees. Plus 2. Sine? Well, let's go back at sine and cosine. Really, we can think of the sine curve here is that it's the same as the cosine, but shifted in 1/4 of the period to the left. So what would could happen over here is that we could say that sine, the equation for this is 10. A doesn't change. Our equation is now sine. K doesn't change. While we're shifting this 1/4 to the left, so our period here is 200 degrees. So we're going to shift this 1/4. What's 1/4 of 200? So 200 degrees divided by 4 is 50 degrees. We shifted to this left so that we can say that this is going to be the same thing as x plus 110 degrees plus 2. So there's our equation for sine and cosine given that information.